Numerical Python, commonly known as NumPy, serves as the fundamental engine for artificial intelligence. While we as humans understand the world through words and images, AI systems operate entirely on massive lists of numbers. NumPy gives us the specialized infrastructure needed to process millions of these numbers at speeds standard Python simply cannot achieve. To truly understand this difference, let's look at a kitchen analogy. Standard Python operates like a single chef. This chef prepares ingredients one by one, chopping one carrot, then one onion. It's highly flexible, but as you scale up, it becomes incredibly slow. NumPy, on the other hand, acts like a high-tech industrial chopper. Instead of handling single items, it processes entire crates of data simultaneously, making it incredibly fast. The secret to the speed lies in how memory is managed. Standard Python lists are heavy. The computer has to individually check the data type of every single item, which creates a lot of overhead and slows everything down. NumPy solves this by using arrays. An array requires uniform data types, meaning every item is exactly the same type. Because of this uniformity, NumPy skips all those individual checks, making calculations lightweight and extremely fast. When performing math, it uses a concept called vectorization, allowing the computer to process an entire block of memory in one single operation. Let's visualize this using Legos. On the left, we have a 1D array. Think of this as a single gray row of Lego studs, a simple line of numbers, where we find items using row indices. In the middle is a 2D array, or matrix. This green base plate forms a grid with both rows and columns, allowing us to pinpoint values with specific coordinates like row 3, call 5. Now look at the right side. This shows the magic of broadcasting. Imagine taking a single red brick and stamping it down onto every single stud of that green base plate at the exact same time. Instead of placing bricks one by one, the operation happens across the entire grid instantly. This efficiency is crucial in the real world. Imagine an e-commerce platform managing a million products. If they run a big sale and need to apply a 10% discount, doing it manually would crash the system. With broadcasting, NumPy updates all 1 million prices instantly. On an even grander scale, NASA used NumPy to process petabytes of data from radio telescopes. By efficiently managing these massive arrays of pixel data, NumPy performed the complex math required to stitch together the first image of a black hole. Implementing this in Python is highly logical. First, we import NumPy as NP. We can take a standard list, the slow chef method, and upgrade it to a high-speed array using np.array, adopting our industrial method. To apply a 10% discount, we simply multiply our prices array by 0.90. That 0.90 immediately broadcasts across every single value. To wrap up, remember that uniform data types are what allow NumPy to use vectorization and achieve such incredible speeds. If you try to mix text and numbers, it will throw a type error to protect that speed. When you combine broadcasting with simple commands, you get the massive payoff of NumPy, turning what used to take years into direct, efficient operations.